Hi guys, I am discussing about projectile motion. In projectile motion, it's a two-dimensional motion. When object in projectile motion, its velocity is resolved into corresponding components, its horizontal components and vertical components. The specialty in the projectile motion, the horizontal component of velocity remains constant, but the vertical component of the velocity changes during its motion. So here you can observe how the velocity of the vertical component is increasing during its motion, but the total velocity throughout the motion remains constant. And when it comes to acceleration, in two-dimensional motion, acceleration is also resolved into the two components, its horizontal component and vertical component. But in projectile motion, the acceleration is only due to acceleration to gravity. It only acts in the vertical direction. There is no horizontal acceleration direction. So we will discuss a question. The question is projectile fired parallel to horizontal from certain height. So under this question, we need to derive certain mathematical equations. The first one, what is the trajectory of the path? The path, the route taken by the object, is having certain shape. That shape in mathematics having certain name. We need to find whether it is a circle or ellipse or a parabola or hyperbola, like that. With the help of mathematics, we are going to figure it out. And not only that, we are going to find what is the time of flight, means the time taken to reach from initial point to final point, which is known as time of flight, and the horizontal range, the maximum distance which is covered, which is known as horizontal range, and velocity of the projectile. So throughout the projectile, the velocity remains constant. What is the velocity of the projectile during its motion? So this is the question which I am going to discuss under the projectile motion. So here I am going to stress again 2 points. So the 2 points is, suppose in the absence of air resistance while doing projectile motion, so we will neglect, there is no air resistance. So air resistance is absent. So then the motion is resolved into two components. That is motion along horizontal direction with uniform velocity. So that is the motion due to horizontal direction, that is the velocity x-axis which is uniform. And second one, motion along vertical direction under gravity. So motion along vertical direction, so velocity under the vertical direction, and this is going to change. But acceleration due to gravity, we represent along y-axis is constant. So these two are the two key points. Again I am stressing the key points. So in the two-dimensional motion, the motion is two independent motions. One is motion along horizontal direction with uniform velocity. Here I can represent that Vx with uniform velocity, and motion along vertical direction under gravity, that is with uniform acceleration due to gravity. So these 2 points are very key points to derive the expression. So let us do it. Consider as like in the given situation, xy is a two-dimensional plane. An object which is at point O, which is at a height h from ground, is throwing with a initial velocity u. Suppose the object takes the path of like this. So I would like to take a point, a location which is point P. So this is at a distance from x-axis. So this is the location of y, and the same point corresponds to the point which is goes to x-axis. Now at this point the object having two velocities, so that is the velocity along horizontal component vx, so that is remains constant, and the vertical component, that is vy, so that is the velocity in the vertical component. And the resultant velocity, if I take the resultant velocity little thick vector, so the resultant velocity of these two is representing in the direction. So this is the resultant velocity of the two components. So this we can represent that v is the resultant velocity. Now if the object is dropped at a distance of a from ground, so this perpendicular distance we call as range. The point of landing of the object from the base point, which is known as range. So here I need to figure it out. The very first thing, let me take what are the given there. The first one, the object having uniform horizontal velocity. So in projectile motion, that is the very key point, uniform horizontal velocity. So here I can take that uniform horizontal velocity as u. And the second point, it is the vertically downward acceleration motion. Vertically downward acceleration motion, accelerated motion with constant acceleration. With constant acceleration, that equal to g. So these two are the key ingredients to solve our next components. Now first, to find the trajectory, so we need to find the trajectory of the path. Trajectory of the projectile. Now after releasing the object at an instant time t, suppose the object reaches to a point P, that is P of x comma y. So at this point P, the horizontal distance covered by the body in the time, the horizontal distance, covered by the body in time t is, I need to find the horizontal distance. Here be careful, distance also resolve into two components. One is horizontal distance and vertical distance. Here the horizontal distance means nothing but x. So the distance, horizontal distance x equal to the horizontal velocity. The horizontal velocity here, the component of u times t. So therefore time t equal to x upon u. So we got the time expression. Now after that, the vertical distance. The vertical distance traveled by the body in time t is the vertical distance, means here I need to find vertical distance as y. So this is, we need to figure it out. To find the vertical distance, here we use the second equation of motion, that equal to, since s equal to ut plus half at square. Here s means nothing but the vertical distance as y, the perpendicular distance y. So if you can use this equation, since s equal to y, s equal to y, so I can write that as y equal to, so y equal to, in vertically the velocity component goes to 0, because the velocity component is only horizontal component, there is no vertical component of velocity. Now this times goes to 0 of t plus half, and acceleration, so that is we consider as acceleration due to gravity, so that goes to z times t value as it is like that. So here I'll mention what the conditions I have taken at here. So there is no vertical velocity, therefore the vertical distance s equal to y, and the vertical component u suffix y velocity goes to 0. So these are the two cases we observed, sorry, we use it here. Not only that, acceleration a place is replaced with a acceleration due to gravity. Now let us solve this expression. Now I'll get it at here, y equal to 0 times t value goes to 0, so we can end that half gt square. Substitute the t value what we got from above, so y equal to half g times x by u whole square. If you can do further calculation, this will be changes as, so half g x square upon u square. This I am writing some modified way, g of 2u square times x square. So the y equal to g upon 2u square times x square. So this I can write that some k times x square. So k is a constant which do not change at here. Y equal to kx square. Since here k equal to, I consider g upon 2u square, because g is constant and u initial velocity is also constant. So if you can divide, that gives expression. So this is a mathematical expression for a shape known as parabola. So in mathematics, a straight line, suppose this is straight line, so it is having its name, its equation. Suppose if I draw a straight line, so this is straight line, it's arrow. So this is straight line. This straight line we represent in the mathematical equation, that equal to y equal to mx plus c. And for circle, it is also having equation x square by y square, x square by a square plus y square by b square equal to 1. So different shapes are having different mathematical equations. So this equation represents that given trajectory is a parabola, or we can write that this is a quadratic function in terms of y, which is a function of x square. So the trajectory of the projectile is a parabola. So now you remember parabola mathematical expression, that equal to y equal to kx square. Here the k becomes any kind of constant. Here the k value equal to g upon 2u square. So that's how we derived the expression for trajectory and the shape of the trajectory. Here this trajectory shape is known as, this shape we known as that parabola. So if an object throws in 2 dimensions, the trajectory of the object is always a parabola. It's kind of shape. Now let's jump into the term which we need to calculate. That is known as time of flight. So time of flight means nothing but the time taken, the total time for which the projectile remains in its flight. Or if you take in the diagram, the time taken by the projectile from point O to from point A to reach from point O to from point A, the time taken by the projectile is known as time of flight. Now I am considering, let the time of flight that equal to from O to A, which equal to capital T here itself. Now if this is time of flight capital T, to find the time of flight, so again we can use that second equation of motion, that equal to S equal to ut plus half a t square. Now here S equal to the horizontal distance height and t, little t equal to the capital T itself, the time of flight itself. Now if you can change the above expressions, and we know that initial velocity u equal to in the vertical direction is 0. So this is expression we used to take only in the vertical direction, because the displacement is always happening in the vertical. The change in position is happening in the vertical direction. So that's why the displacement we will take always in the vertical direction. Now S equal to ut plus half at square. So now you can substitute and get the final result. H equal to 0 times t plus half. Here a equal to g itself, g times t square. So here I wish I need to represent that a equal to g. Now we shall further simplify. So 0 times t gives the 0 itself only, half g t square. Now t square equal to 2h upon g, that implies time of flight t equal to square root of 2h upon g. The total time taken by the projectile to reach from starting point to ending point is known as time of flight. Here the time of flight is purely depend upon the height. At what height from we are releasing the projectile, and the acceleration due to gravity, t equal to square root of 2h upon g. Now the next thing we need to figure it out, that is very important thing, which is known as range. Range is nothing but the horizontal distance. It's the horizontal distance covered by the projectile during its time of flight. The horizontal distance covered by the projectile during its time of flight, which is known as range. So I can write that range equal to horizontal distance covered by the projectile during its time of flight. The horizontal distance covered by the projectile during its time of flight is known as range. Now here we need to calculate the horizontal distance. Okay. Now this is very simple. What is the distance formula? Or we can get the velocity equal to distance upon time. So here the distance I am calling horizontal range, so it is the range upon time. So velocity, but here the velocity is horizontal velocity, not the vertical velocity. The horizontal velocity component times t equal to time of flight, which equal to gives the horizontal range. So we can write that range equal to horizontal range. So range r equal to horizontal velocity times time of flight. So in the figure, range is nothing but the distance covered. So here you can see the horizontal distance from the initial point to final point is known as the horizontal range. It's also nothing but a distance. So that horizontal range we can get by multiplying horizontal velocity with the time of flight. Therefore r equal to horizontal velocity, we got it. The whole projectile is having one and only horizontal velocity because the same initial velocity, only the horizontal velocity. The horizontal velocity component remains constant throughout the projectile motion, remains constant. Please remember this point carefully. So with what velocity you are throwing a projectile from a certain height, that velocity remains same throughout the projectile motion. That velocity do not change. Only the vertical component of velocity is going to change. So I don't know how much you are able to get this point. So horizontal velocity u throughout the projectile motion, it remains constant. So that multiplies with the time of flight, that is a capital T. So range equal to u times time of flight equal to under root of 2h by g. So the horizontal range r equal to u times square root of 2h upon g. So this is the expression for horizontal range. So horizontal range purely depends upon the initial velocity of the object and h and acceleration due to gravity. So to increase the range, what we need to do? We need to increase the initial velocity. So this is the great technique where we release a missiles, especially land to land missiles. So these things we need to keep it observe. So if you to cover long range, so there should be a greater initial velocity, or if we cannot achieve greater initial velocity, we need to take the help of the greater height. So that's the reason if you going to launch a missile from greater height than the sea level, so the component of the velocity is reduces. Now let us find the final concept, the final one, the velocity of the projectile at any instant. The velocity of the projectile at any instant. What is the velocity of the projectile at any instant? So the velocity of the projectile at any instance remains constant. So how can we get that? We know that in 2 dimensions the velocity is resolved into 2 components. Suppose this is projectile motion. So if you can take the velocity at any point, it is resolved into 2 components, horizontal component and vertical component. There is a change in the vertical component, but the horizontal component remains constant. So throughout the projectile motion, the horizontal component remains constant, but the vertical component is changing. So at any instant, I consider a point P. At that point P, at any instant time, at any instant time, the velocity v has two rectangular components. The velocity v has two components. So the horizontal component, so that is the what the velocity we throw on the object. U is the horizontal component. So this component remains constant throughout the projectile motion. So the horizontal component of velocity, here I am supposed to mention horizontal component of velocity, Vx equal to u, and another component is vertical component. And the vertical component of velocity, that equal to v suffix y. So the vertical component of velocity v suffix y equal to this, this component is going to change. So this we write it from the first equation of motion. Suppose if you can take the first equation of motion, that equal to v equal to u plus at. So here the u, initial velocity in the vertical component, since I am writing about only vertical component, there is a y. So there is no vertical component initial velocity. Since we throw object horizontally, so I did not throw object vertically. So we throw on the object horizontally. So the velocity vertical component, initial vertical component was to 0. And here the acceleration, acceleration due to gravity, and t here itself. So the velocity vy equal to 0 plus gt. So this is the velocity of the vertical component. Now we got the two components. So the one and only thing we need to find the resultant velocity. The resultant velocity at point P is the resultant velocity. We know how to find the velocity resultant v equal to the magnitude of vx square plus vy square. Yeah, we got it, the two components substituted here, vx equal to u square and vy that equal to just I drop 0, I can get gt square. So the velocity magnitude equal to square root of u square plus g square t square or gt whole square. Now if this is the velocity magnitude, what about its direction? Suppose this velocity, the velocity v is making an angle theta with the horizontal component. Suppose this angle, I take an angle, arbitrary angle as beta. If the velocity v makes an angle beta with the horizontal, if the velocity v makes an angle beta with the horizontal, so then we need to find tan beta. So we know that tan beta equal to velocity y component upon velocity x component. So here velocity y component that equal to gt upon velocity x component goes to u. So tan beta equal to gt upon u, or beta equal to direction tan inverse of gt upon u. So this is the expression for direction of velocity. So throughout the projectile, the velocity expression v equal to square root of u square plus g square t square, and its direction and its direction tan beta equal to gt upon u. So these are the different parameters we need to figure it out during the projectile motion. So this is the one of the case when object is thrown from certain height h. So here I am requesting you to remember very carefully. It's two important points. Those are uniform horizontal velocity, so that is remains constant throughout the projectile motion, and there is no vertical component of velocity, initial velocity in the projectile motion, and one and only vertically downward accelerated motion, that is due to because of acceleration due to gravity. So by using this all, we figure it out the trajectory of the path, and next time of flight, and the horizontal range, and velocity of the projectile at an instant, and the direction of the velocity. So this is the projectile fired parallel to horizontal. But we have very different case other than that. Suppose if a projectile fired not from a height with an angle theta with the horizontal. Suppose I thrown an object with an angle theta. So this is an object which is making an angle theta. So this makes a path of this like this. And this path is also known as parabola, and this motion is also known as projectile motion. But this is not projected from certain height, it is projected with an arbitrary angle with the horizontal. So in this case also we need to figure it out the same things, equation of trajectory and time of flight, and same maximum height. What is the maximum height it reaches? This is extra maximum height, and horizontal range. The same things we need to figure it out, but a different case if a projectile is projected with an angle with the horizontal. Here there is no height. So here there is no height. Again the things going to change. How the velocity components and acceleration due to components are going to change. Let us see that in another lecture.